So in that last video, we came across a scenario where it was going to be difficult to factor this. And so I made a note about quadratic formula. And what the quadratic formula lets us do is it lets us solve absolutely any quadratic equation that we have where we have some A, B, and C. So when we are solving the quadratic equation, something that's key is that we need to have this form 0 equals ax squared plus bx plus c. And I really want to emphasize that we have 0 on one side of the equation. So if we don't have 0 on one side, then what we need to do is move things such that we do have 0 on one side of the equation. Okay, so we're going to have some value for A, some value for B, and some value for C. And with that, we plug into this formula right here. And what I just like to do is I'm going to do it to the side here where I have A in blue, B in red, C in green. What I'm going to do is just rewrite this. So we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. And I'm just going to write in our letters there so that we can see where the values will go. So it's just a matter of substitution and plugging in and then simplifying. And in terms of simplifying, I think of this as being in 3 sections. It's like we have this negative b portion, we have this square root portion, and then we have this denominator. And what we're going to work on is simplifying those 3 pieces. And then we're going to get our 2 scenarios, one where we're adding the values in the numerator and one where we're subtracting. So what we're going to do is go through lots of examples here for how to do it. So this first scenario, 3x squared plus 5x minus 4. So this is a case where we have A equals 3, B equals 5, and C equals 4. Sorry, negative 4. And just double checking that we do have 0 on one side of the equation. Now, we could have gone through the steps of trying to factor this, and maybe that would have worked. The thing is that sometimes factoring is nice, sometimes it's not, and when it's not, this quadratic formula works. It also works when it is factorable, so it's really up to you of how often you want to use the quadratic formula, because you can apply it to every single quadratic equation. Okay, so I'm going to set up my format here of x equals negative b plus or minus square root of b squared minus 4ac, and just using parentheses will be super helpful, especially for those negative numbers. So negative b, so this is going to be a negative 5 plus or minus the square root of 5 squared minus 4 times 3 times a negative 4 all over 2 times 3. Okay. So our 3 sections, we have the negative 5 plus or minus. In the denominator, we have a 2 times 3, which is 6. And then the square root, I'm going to simplify using a calculator to help out. What we can do is just plug that in all at once. So I'm going to plug in everything that's underneath the square root. So that 5 squared minus 4 times 3 times negative 4. Which is a 73. So we're going to have negative 5 plus or minus the square root of 73. Now that is not a perfect square, so what we're going to have is we're just going to keep it like that, and we're going to split into our 2 scenarios. One scenario, we're going to have addition in the numerator, so negative 5 plus the square root of 73 over 6. And then the other scenario is where we'll have subtraction. So negative 5 minus the square root of 73 over 6. And with that, I'm going to go back to the calculator. And I'm going to start a fraction where we'll have negative 5 plus the square root of 73 over 6, which is 0.5809. And then the other solution is coming from if we have subtraction in that numerator. So I'm just going to edit my equation here. So if we had, sorry, I typed in 72 instead of 73. Let's go back to that first one. Sorry, that should be a 0.5907. All right, and then with the subtraction, with that correct square root in there, is a negative 2.2573. So what this is giving me is our x-intercepts for our quadratic function. So our function 3x squared plus 5x minus 4, that's going to have an x-intercept at this like 0.590 and negative 2.260. And let's take a look at that with our graph. So let's say I graph the function 3x squared plus 5x minus 4. I feel like positive 3x squared plus 5x minus 4. Okay, we're good. So we have an x-intercept at negative 2.257 and an x-intercept at 0.59. So what we're doing is we're solving for where we're crossing that x-axis. Now keep in mind that we have those three different cases. We can have two solutions like we're seeing here. We could have one solution, and what that will look like typically is that this square root section of our quadratic formula, that would turn into a 0. So all you'd have is the fraction of negative b over 2a, which should sound familiar from our vertex because that's exactly the point that would be our x-intercept. And then the other case is where we don't cross the x-axis, which is totally fine. And what's going to happen with those is when we go to take the square root, we would be trying to take the square root of a negative number, which we cannot do. So that would be a case where we have no solutions. So those are kind of our three cases that can come through. All right, let's take a look at another example here. So 8x squared minus 2x minus 1 equals 0. So we have 0 on one side of the equation. We're going to have a equals 8. B equals negative 2, and C equals negative 1. So we're going to go x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm just going to plug in my values. So we're going to have a negative 2. We're going to have negative 2 in parentheses squared. We're going to have negative 4 times 8 times negative 1, and then in the denominator 2 times 8. All right, so simplifying. A negative 2 is a positive 2, plus or minus. In the denominator, a 2 times 8 is 16. Then with the square root, we're going to be taking the square root of, let's see, negative 2 squared will be a positive 4. And then we have minus 4 times 8 times negative 1, which is 36. And actually, we can take the square root of 36, and that would just be 6. So that right there is coming from the square root of 36. All right, so now we can split into the two scenarios. So for one of them, in the numerator, we'll have 2 plus 6 divided by 16, and the other will have 2 minus 6 over 16. Actually, I can just reduce these here. So this is 8 over 16, which is 1/2. So that's one solution. And then the other solution, we'd have a negative 4 over 16, which is a negative 1/4. And there's our two solutions. All right, so these next ones here, a little extra step at the beginning with the idea that we want 0 on one side of the equation. So x squared plus 7x equals negative 2. Because I need to have 0 on one side of the equation, I'm going to add 2 to both sides of the equation. So here I have x squared plus 7x plus 2 equals 0. I could try to factor it, but actually this isn't going to be factorable. So if I want to solve for those x-intercepts, I need to use the quadratic formula. So a equals positive 1, b equals 7, and c equals positive 2. So I'm going to set up my format for the quadratic formula, making sure I plug in everything correctly. All right, negative b, so that's negative 7 plus or minus 7 squared minus 4 times 1 times 2 all over 2 times 1. All right, so we're going to have x equals negative 7 plus or minus the square root of, let's see, 49 minus 8, so that's a square root of 41, which is not a perfect square, so it's just going to stay as a square root of 41. And now we're going to split into our two scenarios, one where we add in the numerator, one where we subtract in the numerator. So with this one and that kind of messy square root, I'm going to go ahead and use the calculator to help out. So we're going to have a fraction with negative 7 plus the square root of 41 over 2. And that's going to be a negative 0.2984. And then if we had subtraction in the numerator, that would be a negative 6.7016. And those would be our x-intercepts to this graph, x squared plus 7x plus 2. All right, our last one here. So we have a 2 times x plus 1 times 3x minus 1, and that's equal to 1. So something that's happening here is that we have our factored form, which could be nice for finding these x-intercepts, because we could use that product of zeros rule. However, these are not multiplying to equal 0. They're multiplying to equal 1. So we need to move that 1 to the other side of the equation, which actually means I need to multiply all of this out. So I'm going to start simplifying this left-hand side. The 2, you just distribute into one of the set of parentheses. So that x plus 1, we're going to have that be 2x plus 2. And then this is still multiplying a 3x minus 1, and then equals 1. And now we're going to FOIL. So we're going to do first, outer, inner, last. So 2x times 3x is 6x squared. We're going to have, let's see, negative 2x plus 6x, so that's a positive 4x in the middle. And then positive 2 times a negative 1 is a negative 2, equals 1. And now I can get 0 on the other side of the equation by subtracting 1 from both sides of the equation. So 6x squared plus 4x minus 3 equals 0. All right, so we're going to have a equals 6, b equals 4, c equals negative 3. And setting up our quadratic formula, b squared minus 4ac all over 2a. So negative 4 plus or minus 4 squared minus 4 times 6 times negative 3 all over 2 times 6. All right, so negative 4 plus or minus. In the denominator, we're going to have a 2 times 6, which is 12. And then up here, I'm going to use a calculator to help me simplify that square root. So that square root there is 16 minus 4 times 6 times negative 3, which is positive 88. So we're taking the square root of 88. And actually, I'm thinking, let's look at this case where we simplify to an exact answer using our square roots, just in case. I'm trying to remember if it comes up in my open math. If it doesn't ask for an exact answer, then we would just put this in the calculator as we've been doing to get those decimals out. But let's say we wanted to simplify this. So let's get a quick review of radicals. So square root of 88. And what'll be helpful is to remember kind of what our perfect square values are. So like 1 squared, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, 36, 7 squared, 8 squared, 9 squared, and 10 squared. Okay. So having this list of perfect squares can be helpful because what we would do is if we want to simplify this, we want to see if this is divisible by any of our perfect squares. So 88, what I'm thinking is I can divide a 4 out of that. So I can express the square root of 88 as a 4 times 22. Then I would just look at that 22 and see, are there any other perfect squares that go into it? Which there are not. So with that, what I can do is separate this up as the square root of 4 times the square root of 22. And that square root of 4 simplifies to 2. And then we have the square root of 22. So what I can do is simplify the square root of 88 to this 2 times square root of 22. So what I'm going to do is rewrite our quadratic formula here as a -4 plus or minus 2 times the square root of 22 over 12. And then what I could actually do is a step to simplify this is seeing, again, thinking of those 3 sections. So we have this -4, we have this 2 root 22, and we have this 12. If there's anything that divides into all 3 of those pieces, you can take out that common factor. So like there's a common factor of 2 in each of those. So what I can do is simplify this to, well, -4 divided by 2 is a -2, plus or minus, so 2 root 22 divided by 2 would leave us with just that square root of 22, all over 12 divided by 2, which is 6. So this right here would be the exact form of our solution. So the steps that are in there is simplifying the radical and then seeing if there's a common factor that can come out of absolutely everything, each of those 3 pieces of our calculation. And then to get a decimal here, again, we would just split up and use the calculator.